Hello, today we want to discuss for the consultation hour for the topic 4. Now look at the question number 4. Figure 4 shows three objects A, B, C are kept in static equilibrium. The mass of B is 2 kg. Object A is just about to slide on the table. The coefficient of static friction between A and the horizontal table is 0.3. Calculate the mass of C and the mass of A. First, we need to start with the concept of static equilibrium. We know that for the static equilibrium, for the Newton's first law, therefore, the net force acting on the object must be equal to 0, meaning the total force at x-axis equal to 0 and also the total force at y-axis is 0. Now, look at the diagram first. This is the first string, the green color. Okay. Then this is the second string, red color. And then this is the third string, the black color. So we can label as a T3, T1 and T2. So look at the free body diagram on the object A. So for the object A, so we have normal on A, WA, static frictional force, Fs, and then this is the tension acting on A. Then for this point, so this is the force T1, and then this is the direction of the tension T3, and then this is the direction of T2. We know that T2 equal to the weight object B. Then, when we draw for the free body diagram for object C, so this is the T3, and then this is the WC. Alright. Then, if you want to transfer into X and Y axis, so this is referred to free body diagram object A. So this is the Fs, WA, first tension and normal for the object A. Then for the object B, this is T1, T3 at certain angle, and then this is T2, the magnitude equal to the weight of object B. And the third free body diagram for object C, so this is T3, this is the weight of object C. Now, we need to write the equation for each axis. Look at the object C. So this is the sum of force acting at x-axis for object C. And then this is the net force acting on object C at y-axis equal to 0. Then refer to the free body diagram, object C, upward and downward. Therefore, we can write this equation. Next, for the object B, so we can write the net force acting and X equal to 0. Then when we resolve T3, so we get here should be your T3 at y-axis, and this one become your T3 at x-axis. Then for the T3x axis, so this is become positive to the right. T1 become negative because of to the left. So we can write for this equation. And then for the y-axis, so upward T3y, downward T2. So we can write like this. Therefore, from the concept, we can write the equation for number 4. Next, for object A, look at the x-axis. This become positive and this one to the left, therefore negative sign. Upward and downward. So we can write for the x-axis and the for y-axis. Now look at the first equation. Okay, look at the first question. We want to determine the mass of C. So we can use equation number 4. So just rewrite T3 sin 45 minus MBG equal to 0. And then from here, we can determine the value of T3. After that, when we use the equation 5, so this is actually equation 5. And then we can determine the value of object C. Next, calculate the mass of object A. So from equation 3, so we can write here T cos 45 minus T1 equal to 0. So we can determine the value of T1. After that, we use equation 1, T1 minus mu and A equal to 0. Then substitute the value of coefficient of static friction, mu, and then determine the value of normal force. Then, from equation 2, so NA minus MAG equal to 0, then substitute the value of normal force. So we can determine the value of mass A. Next question. A box of mass 4 kg rests on a horizontal surface. When the box is pulled by the horizontal force 20 Newton, it moves with an acceleration of 2 meter per second square. Calculate coefficient of kinetic friction. Actually, this is the mu. And then, the acceleration of the box if the horizontal force replaced by another force 60 Newton at third 30 degrees above the horizontal. Now, look at the first question. Okay, actually this is the diagram refer to the statement. First step, we need to draw a free body diagram on the box. We have frictional force, normal, weight, and the applied force 20 Newton. Next, look at the acceleration here. So this acceleration located at x-axis, meaning your x-axis become Fx equal to ma. Therefore, the net force at y-axis become 0. Next, refer to the direction of A. So, any force that same with the direction of acceleration become positive, meaning this force 20 Newton positive and the frictional force is negative. Therefore, we can write in terms of equation s-axis. For the y-axis, upward force positive, downward force negative. So therefore, we can write as n minus mg equal to 0. To calculate the coefficient of kinetic friction mu k, so refer to the equation 1 and then substitute the value of acceleration is 2 meter per second square and then mass 4 kg. So we can determine the value of frictional force. Next, using the equation 2 from the y-axis, so we can determine the value of normal force. Then, substitute into the frictional force equation. And then we can determine the value of coefficient of kinetic friction without unit. Next, we need to determine acceleration if the applied force replaced with 60 Newton with angle 30 degrees. Next step, so look at the acceleration here acting at x-axis. Therefore, your x-axis become F equal to ma. Then, your y-axis become 0. Next step, so we need to resolve the 60 Newton force into x and y axis. So look here, for the x-axis, 60 cos 30. For the y-axis, 60 sin 30. Next step, look at the x-axis. So we have 60 cos 30 and the frictional force. Check which the force or forces are same direction with your A. This is become positive, this is negative. Then we can write in terms of this equation. So maybe we can label as first equation here. Then substitute the value of the mass 4 kg and then previous frictional force is 20 Newton. So determine your acceleration. Next, question number 6. You stand next to a wall on a frictionless skateboard and push the wall with a force 40 Newton as shown in figure 4.5. Okay, basically this is refer to the Newton third law. Okay, when the boy stand next to a wall, this force we call as action force. So the value is 40 Newton. What happened? So the wall will react to the boy. So the reaction force also 40 Newton. But negative direction because of the reaction force is to the left. How hard does the wall push on you? So basically from the Newton third law, when you push with 50 Newton to the wall and then the wall pushes back with 40 Newton but in opposite direction. Question B. If your mass 80 kg, how much would you accelerate? So refer to the F net equal to MA. Right. And then substitute the value of mass and then the value of the force. Then determine your acceleration.